Okay, hello everyone. Welcome to my class of medical statistics. I'm your teacher, Gao Feifei. Last class, we have completely discussed the definition of statistics and the steps of statistical work. We have known that statistics is a branch of science that deals with the art of collecting, classifying, displaying, analyzing, and interpreting results from research. There are 4 steps of statistical work, including statistical design, data collection, data management, and data analysis. And statistical design is the key step of statistical work that guides the other 3 steps. After we have known the definition of statistics and the steps of statistical work, to obtain a complete understanding of statistics, it is necessary to be able to speak its language. The following definitions are intended to give us a general understanding, including population and sample, parameter and statistics, sampling error, probability and small probability event, and variable and data set. You must grasp and understand those concepts exactly. We will often use those concepts in our latest study, and those are also the important topics of your middle term examination and final term examination. So you need to pay particular attention to our today's class. Now, let's talk about those concepts one by one. The first is the population. Once we conduct a research, what we are interested is making inference or generalization about the population. So the population must to be carefully and well defined. Population is a collection or set of individuals, objects, or measurements about whom we wish to make an inference. The population contains the values of all the observations that we have determined according to the purpose of our research. For example, if we want to research the height status of your class, now firstly I need to measure the height value for each student. Now, the height values of all the students in your class is a population for our research. Suppose that there are 100 students in your class. Now, the height values of those 100 students is a population. This population contains 100 height values. Because the population contains the values of all the observations, so it is the largest collection of values of a variable. In general, different research have different population. It was determined by the purpose of your research. The purpose of your research is changed. Now, the population is also changed. For example, now if we don't want to study the height status of your class, but now study the height status of this school, Jinzhou Medical University. Now the purpose of our research is changed. Now the population should be the height values of all the students in this school. not the height values of all the students in your class. But because the objective of our research is changed, now the population is also changed. The population contains all the values of all observations that we are interested. Another example. Now, if we want to study the weight status of an elementary school, now, first we need to measure the weight values for each student. Now, the weight values of all students in this elementary school is the population. It's also the population. Also contain all the values. According to the number of observations in a population may be finite or infinite. If the number of observations in a population is not too large, we can find out each observation and we can get the exact value of each observations. Now, such population, we call it as finite population. For example, if we want to study the height status of your class, now all the students of your class, maybe 100 students. Maybe 100 students in your class. Now, the height values of those 100 students is a population. Just have 100 students. The number of observations is finite. So, such population, we can call it as the finite population because the number of values is finite, is limited. So, it is a finite population. But if the number of observations in a population is very large, or we can't get the exact number of observations, such a population, we call it as the infinite population. For example, if we want to study the height status of adult males in China, now, the population is the height values of all adult males in China. There are so many adult males in China. We can't get the exact number of adult males in this population. And the number of adult males in China is changing all the time because some are dying and some are becoming adult. The number of adult males in China is changing all the time, and the number is very large. We can't get the exact number of observations. Such population, we call it as the infinite population. So the population can be divided into two categories: finite population and infinite population. It is the definition of a population. But in general, the number of observations in a population is often very large. In general, it's very large. Sometimes we don't have enough manpower, material, or financial resource to research everyone. In this situation, we usually randomly select part of observations to research. Now, those part of observations which was selected from the population is called as the sample. So, sample is a part of a population. It is a subset of the population. It just contains part of observations of the population. The number of observations in a sample is limited, so we can measure the values for each observations. We can get the exact values for each one. For example, suppose that there are 100 students in your class. Now we know height values for all those 100 students is the population. But now if I don't have enough time to measure the height values for everyone, now I just randomly select 20 students to research. I measured the height values of those 20 students one by one. Now I will get 20 height values of those 20 students. Now height values of those 20 students is the sample. It just have 20 values, not all the values in the class. There are 100 students in your class. Now 100 values was the population, but now I just select the 20 values from this population. Now those 20 values is a sample. Clear? Okay, another example, suppose that there are maybe 1,000 students in elementary school, but now the weight of just 200 students was studied. The weight values of 1,000 students is a population, but now we just measured the weight values for 200 students. Now the weight of those 200 students was our sample. So the sample just a subset of the population. After we have selected a sample, now we can collect data from our sample, and we can conduct different methods to describe the characteristics of this sample. But what we are interested in is the characteristics of the population. We are interested in making generalization of the population, not the characteristics of the sample. So now, the characteristics of the sample will be used to infer the generalization of the population. That's about the inferential statistics. It is about the inferential statistics. Now, this figure vividly showed the relationship between the population and the sample. We can see that population is the complete set of subjects that we interested. But this set is too large. Maybe we don't have enough manpower to research the observations, each observation in this set. Now, we randomly select part of subjects to research. Now, part of subjects that was selected from the population is a sample. It is a subset of the population. After we conduct different methods to describe the characteristics of the sample, now the characteristics of the sample will be used to infer the population, to get the characteristics of the population. Now, the process of select part of observations is called sampling. So the purpose of sampling is to select a random sample to represent the population, and then we describe the sample, describe the characteristics of a sample, and then infer the characteristics of the population. That is the relationship between the population and the sample, and what is the population, what is the sample, and the relationship between population and the sample.